Guru. Today we will see some important and interesting QA or testing interview questions. This is mainly about the differences of the basic testing types or testing terminologies that we will see in the coming slides, but these are really famous and have been asked a number of times. I myself have also asked in some of the interviews for the QA or testing related positions. So let's go through and see one by one. The first important question is the differences between test strategy versus test plan. So these are the terms that often get confused by the testers or anyone actually within the test team. And some organizations may have actually just one of this document or one of this process where everything is combined if it is really a small company basically. So they can have a test strategy which is a combination of both test strategy and test plan. That is the actually reason for some people to get confused about these terminologies. But I'll try to differentiate and then tell you what are the differences, and some of this information is taken from online, and I have taken some sites, help of those sites, and tried to summarize that information here. The first thing, test strategy. So, test strategy is a document that is basically created at the organization level, and this is a high level document. It is describing the way testing will be carried out in an organization. This is really important to underline. The way testing will be carried out in an organization. It basically aims at providing a systematic approach to the software testing process. So basically it's talking about the systematic approach. If someone is new to the organization, if they want to understand what is the test strategy that I should follow within this company. So this is the best document for them to go through first, which will give or outline the main important things about testing and the test strategy. Then what about test plan? Test plan is the document that is created at the project level. When we say document here, it doesn't necessarily to be a document. It could be a Confluence page or a wiki page where you are actually giving the information or details about what is the test strategy, and then test plan is generally created at the test project level. So what is a test plan? It is a formal document derived from requirement documents. So you have a lot of requirements or user stories, or either it is a document or the information available in the ALM system, and you are referring to those requirements and creating the test plan. It basically describes in detail the scope of testing and the different activities performed during testing. So what is the scope of my testing, and also not in scope, what am I going to do during the testing, what are the activities I am going to perform, all this information will be written down in the test plan. So this is the first difference that you need to explain. Test strategy is created at the organization level to describe the way testing will be carried out in an organization, and test plan is derived from the requirement documents which describes the scope of testing and different activities performed during testing. Okay, then what this document should contain, the test strategy. This is a vision of testing. So it should contain the test objectives at the high level, why we are doing and what we are doing, then test approaches. When we say test approach, it could be manual or automation or using some backend testing methodologies like API testing. And then how we are going to keep our test data and how we are going to manage the test data, and what is the process for backing up and restoring, and what sort of databases we have, how we are inserting the test data, if we have any tools for test data creation. This is all the information that we should provide under this. Also the dummy data or production data following company's guideline, that also need to be used here. For example, if you are using some real data, that needs to be masked for security reasons, and also if you are using some dummy data, how that is created or is being used, the general guidelines around it needs to be mentioned. Then what are the testing tools we have? It could be either the defect management tools or test management tools, or the other automation tools that you are using. So all this information should be mentioned under testing tools. How to download, how to use, that sort of information, like where you get that, the installers, for example, all that information. Then test environments. So because we perform variety of testing within the organization, it is also important to mention what are the environments that are available for testing, and if you have any specific requirements for that testing. For example, for performance testing, you need to have a static environment, and for normal functional testing, you need to have something that can be reusable within the testing team. And then if you want to run automation, then you need to be having some environment that can run all the regression suite. So all that information should be mentioned here. Defect management process. So how we are going to raise the defects, and what is the information that we need to keep for raising the bugs. Like, in general, you need to keep the reproduction steps, which environment the bug is found, if there is any workaround available, and what is the severity of that defect. That sort of information needs to be filled in. And when the defect is fixed, generally the matured companies, they want to also track the RCA, root cause analysis, that will be filled up by the developer once the defect is fixed. So based on that, we will be able to cluster the defects and identify the problematic areas and try to address the issues in that area in a proactive way. That is the purpose of RCA. But defect management itself is a vast subject, but we also need to mention the high level guidelines of defect management in this test strategy document. Then what are the test metrics that the organization would like to see? So, like the KPIs, for example, and if it is the test coverage or automation coverage or the number of defects found or the defect leakage. So there are a number of defects that the organization would like to follow, so they can improve their processes and practices. Then risk analysis and mitigation. So it's not like identifying the risks in this document, but it is about how we are generally following this risk analysis process and the mitigation measures. So that also should need to be mentioned. So it can be carried out when and where it is required, and we can follow this process as a guideline to perform this risk analysis. Then reporting at organization level. So the testing activities needs to be reported, and if there are multiple test teams within an organization, then what those teams must follow, so we can uniformly, holistically can report the testing process or progress, or how soon we are able to release it, and how many bottlenecks we have depending on the number of defects that are open, and the severity or priority of the defects. So organization can make good decisions based on this reporting. So the reporting process, what we need to follow, and how frequently we need to do this reporting, all that information needs to be mentioned. So this is like, if you see, it's a kind of framework that is giving an idea to all the testing teams within the organization to follow certain strategy. So the processes and the guidelines are incorporated well, and we have some good benefit out of it. So we have some good direction actually to follow the testing activities within the company. So this is all about test strategy. And then what is a test plan, how different it is from the test strategy. So this is a blueprint or guideline, we are saying, and that describes test scope, test approach, if it is manual or automation. So the main difference here is this guideline that is describing within the test plan is applied for that project. It is not for the whole company, it's not for the whole organization, but it is for that project. It could be a very small project like 2-3 months of project, and it could be addressing a certain types of requirements by one or multiple test teams. So every team can have their own test plan as well, right? And what generally it should contain: the scope of testing, what is the approach we are following, is it manual or automation testing or both, then when and how we are doing it, then the testing types that we should do. So based on the requirements, we will find out what sort of testing types need to be performed for that project. Then resource planning, who is responsible for what. Then scenarios for test coverage. So what are the high level scenarios or objectives we are trying to cover in the testing. Entry and exit criteria, how each of the test type will be started and ended. Then test deliverables and scheduling to intend testing activities during a project level. So you can have a multiple test deliverables, right? You can have the test reports, you can have the test summary, you can have the defect summary, and you can have the automation artifacts. There are multiple, the test case artifacts. all that will be delivered as part of the testing deliverables, and scheduling to intent testing activities. What is the schedule for those activities during the project? So all that information will be mentioned in the test plan, and this is a template to let other stakeholders know what the testing team is doing and how they are doing for a specific project. So it's kind of information to others, and also it's generally for the testing team also to see where are we and how much we have accomplished and how much is left for that project, and they all follow this test plan so they can follow certain direction, and they don't lessen the distractions and with the amount of other things that we are doing during the project. So it gives a clear cut roadmap kind of thing for the testers to focus clearly on what they need to accomplish, because this is what is communicated to the stakeholders as a plan. So this is what we need to accomplish before we close the project or sign off the project. And test strategy usually doesn't change frequently for a very good reason, because it is at the organization level and it is giving the high level general kind of guideline. So it won't be changed frequently. But whereas test plan can change over time as the project gets updated, right? You have created the test plan before you start with the project, and during the course of the project, if you find something new that needs to be accomplished, for example, in the middle of testing you have come out, you got to know that you need to do some security testing as well. So you can update the test plan whenever you find something important that we need to accomplish as part of testing that needs to be there in the plan, right? So those things can be mentioned, and then the test report, then if you have planned something and if you're not able to accomplish for some valid reasons, then you can mention that in the test report for deviations, right? So this is the main difference for test strategy and test plan. Then let's move on to the next important question. What is QA versus QC? This is also a famous interview question. I have asked it many times to the people who have applied for the tester roles in my companies, in my past companies too. The main difference, let's go into this. QA means quality assurance, QC is quality control. So QA is basically a set of activities focuses on providing assurance that quality requested will be achieved. So it is focusing on providing the assurance, whereas QC is a set of activities that focus on fulfilling quality requested. And QA aims to prevent defects. The aim is to prevent defects. We want to follow the guidelines thoroughly that there won't be any defects during the development of the project. Whereas QC aims to identify and fix defects. So here basically if you have a development cycle that starts from requirement, design, coding, and then going into the testing in general, if you're seeing like waterfall or V's out of models. So in every phase, QA is involved from the beginning of the project, and every phase you are applying some good guidelines to ensure that the processes are followed thoroughly, the requirements are clearly understood, and clarifies what exactly needs to be implemented. So you have certain guidelines when you are following the quality assurance at each and every phase. So that is aiming to prevent the defects. Whereas QC means you are actually executing the code, you are actually doing the test execution. So it is aiming to identify and fix defects, right? And this is a preventive technique. QA is a preventive technique, so it saves a lot of cost by removing the defects or by finding the defects as early as possible in the development cycle. Whereas QC is a corrective technique, so it inculcates some cost. So if you find the defects during the formal testing or during the validation kind of phase, then those defects needs to be addressed. There will be some corrective techniques that need to be applied. So it will be a bit costly compared to the QA. It defines some standards and procedures that need to be adhered in order to meet customer requirements. So all the standards and what are the procedures, like the coding standards it could be, or the testing standards, automation, parallel execution of testing, and the procedures that need to be adhered to in order to meet customer requirements. So everywhere wherever we are doing the designs or requirements or architectural designs or coding or unit testing, in all these things throughout the development, there are certain standards that the whole team need to follow. It's not only for testing team, it's for everyone in the project team to follow. So we are able to meet customer requirements. And quality control, whereas it ensures that standards are followed while working on the product. Then QA is activities are determined before production work begins and performed while the product is being developed. So this is while it is being developed. And QC is activities are performed after the product is developed. So it is generally it comes after. So it comes after QA. QA is throughout, it's there and it is starting from the beginning of the production development, whereas QC comes after QA is done. And quality assurance, this prevents the occurrence of issues, bugs or defects in the application. And whereas QC, it report and correct defects or bugs in the application. So it is preventing the occurrence of the bugs, whereas here in QC it is reporting the bugs and getting them corrected in the application. So as I said earlier, this QA is the complete project team's responsibility, whereas QC is mainly testing team's responsibility. Okay, so these are the big differences. There are a lot of other things when we do in practically, but mainly these are the differences of QA and QC. Let's move on to the next interesting question. Verification versus validation. So this is done in a different way in some different domains like medtech, healthcare, where the security or the regulation standards are pretty high. So where in those domains it is done in a bit different way, but in the normal software cycles also verification comes first and then validation. Let's see what are the differences between these from the experts perspective, and so how we should be using in our projects. So verification is a process of determining if the software is designed and developed as per the specified requirements. So there are requirements, and this process is to determine if it is designed, if the software is designed and developed as per the specified requirements. Validation, it is the process of checking the software, the end product has met the client's true needs and expectations. So this is focusing mainly on the customer needs and expectations, and this is focusing mainly on the software if that is designed and implemented as per the requirements or not. Okay, so the main difference is it's following the requirements, and here we are focusing mainly on the customer's true needs and then expectations. And verification uses methods such as walkthroughs, reviews, desk checking, and inspection. So verification in some places, in some domains, as I said earlier, so it's kind of a static testing. So they use walkthroughs, reviews, and inspections. And whereas validation uses a method such as white box testing or black box testing or other things, where you are actually executing the code, testing it, doing the test execution, and then ensuring if it is meeting the customer needs or not. Verification, it can find the bugs in the early stage of development. So that's why we have verification from the beginning of the software development, like QA, where you are finding the bugs in the early stage of development. And here it can only find the bugs that could not be found by the verification process. So you can already see that this is done first, verification is done first, and validation is done only after the verification is complete. Sometimes there may be a question like this also, just to check whether you have practically experienced or done verification and validation or not. So they may ask you, okay, what should be the order that we should follow, and the questions could be asked in a different format, but basically we need to know that verification is done first and it is starting at the early stage of the development, and validation comes after the verification is completed. So this is very good point actually to question it. When we are doing the verification engineers need to focus on, are we building the software right? Are we building it right actually? So everywhere we need to understand what are the best practices. Are we following the right practices? Are we building it right? Are we focusing on the requirements? Is it adhering the requirements that are specified or not? Whereas validation means it is to focus on, are we building the right software? Is it going to be useful? Is it going to be really useful for the end customer? So that should be the focus. So the focus is different, but the ultimate aim is to have quality in the software. So these are the main differences of verification and validation. Let's move on to the next question. Another interesting question is, what is the difference between smoke and sanity testing? Smoke testing is performed to verify the critical functionalities of the product are working fine. And sanity testing is done to check the new functionality or bugs have been fixed. So this is basically done, for example, if you have an application and you want to check the build quality. So let's say you have a big regression suite that is having a lot of functional test cases, negative test cases, positive, happy paths, unhappy paths, all of that. You are having a big regression suite of hundreds of test cases. But this mock testing is to check the build quality only for the end-to-end or important critical workflows. So you may have them like a little very few. In my previous experiences, I never had this mock test suite more than 70 or 80 test cases. That it's basically to cover the end-to-end suite only to focus on the critical functionalities. So if this mock test is passed, you can say that you can get the confidence that yes, my application is stable. I can proceed with my regression suite now. So that sort of thing. For that reason, you use this mock test suite, basically to qualify the build. And sanity testing is done. This is to check the new functionality or bugs have been fixed. So if there is a specific area where the new functionality is implemented or a lot of bugs in that functional area are fixed, so you will perform the sanity testing focusing on that specific functionality, not the complete application's critical functionality. Okay, so the difference here is it is focusing on the critical functionality, and here it is focusing on the new functionality or the bugs that have been fixed. Then here the objective is to verify the stability of the system in order to proceed with more rigorous testing. As I said, more the next regression suite is the biggest one. Before we proceed with that, we want to check the stability of the system by running the critical path testing. Then for sanity testing, the objective of this testing is to verify the rationality of the system in order to proceed with more rigorous testing. So rationality, whether the particular thing is that fixed. If that is fixed, then I'll proceed further. That sort of confidence it will give. Then smoke testing is run on the initial builds when the software is relatively unstable to gain confidence on stability. So this is also one thing we have discussed. So for example, if you have just started your project and the first few builds, like first 20, 30, 40 builds, you will have a lot of things implemented, like the initial framework will be implemented of that application. So the software is comparatively much unstable. During that situation, you really want to qualify your application by running the critical tests, like are you able to log in or not, are you able to access a particular page or not. So that sort of testing, so you know that yes, if everything, the main key functionalities are accessible or working fine, then you can proceed with the other things. Otherwise it's just time waste, right? You know that it's not working, you will have like 300 or 400 tests of your regression suite will be run, and which will have more than half failed, which is of no sense, right? That's the reason this helps a lot when the builds are unstable. Then sanity testing is run on relatively stable builds. So for example, you have multiple regression runs passed. So you're seeing actually first few regression runs that are passed. Then you know that the application is comparatively more stable now. And so if you want to verify the fixes first, then proceed with the system or regression testing, then you will run the sanity testing. So this sanity testing is something that will be focused on those fixes or on those functional areas where there are a lot of changes. Once those are passed, then you want to run the entire regression suite, or you want to proceed with another kind of testing types like system testing or system integration testing. Once after this, um, you know rationale is resolved, once after the areas that have changed are all working fine. Then smoke testing experiences the entire system from end to end because it's touching the critical parts, like critical workflows of the entire application. And sanity testing exercises only the particular component of the entire system. So it's only the particular functional area where it has undergone some changes. So these are the main differences. I hope now you understand when we use the smoke testing and when we use the sanity testing in the real world scenarios. Let's move on to the next question. Regression versus retesting. So what is regression testing and what is retesting? There is a lot of difference here, but generally people get confused. Often they get confused because maybe the wording regression testing and retesting. So maybe because of that wordings, it may be a little confusing. But let me explain the differences here. Regression testing is carried out to confirm whether a recent code change has not adversely affected existing functionality or features. So I have my application running and there are some code changes that are made recently. So all the test cases that are passing or the application, the functionality that is running, it should not be adversely affected because of these recent code changes. So that means it should not be introducing any bugs to the existing functionality. For that reason, we run regression testing. And when we run retesting, retesting is carried out to confirm the failed test cases are passing after the defects are fixed. Let's say you have run one regression test suite and there are some 10 defects resulted from that regression testing. You have filed those bugs and now the bugs are fixed. So you will be running only those 10 test cases that were failed earlier. You will not need to run the entire testing. And based on the impact of those defect fixes, if they identify that certain functional area is the one that is impacted with these bug fixes, then you will focus on only that particular portion to run your retesting. So defect verification is mainly the focus for retesting. Regression testing is performed for all the test cases in the regression test suite. So if you have 300 test cases in your regression or 500, you will be running all of them in the scheduled time for regression testing. Whereas retesting is done only for the failed test cases. Regression testing checks for unexpected side effects of any code changes in the latest build. Retesting makes sure that the original fault has been corrected. Okay, so the focus of regression testing is to ensure that there are no side effects. I know that there are some code changes and there are no side effects on my existing functionality because of the code changes in the latest build. Retesting, whereas, make sure that the original fault has been corrected. I know there is a bug and now that bug is corrected. It's working fine. The test cases are passed. That is the focus of it. Yeah. So now I hope it sounds clear. Let's move on to the next and last question from this list. So often people get to ask severity versus priority of defects because they may get confused and it is being used interchangeably in some cases. Even in the day-to-day life also, sometimes I see people get confused with this is the severity or this is the priority, and they say interchangeably. So it is important actually to know why we are using and what they are referring to, so in our day-to-day life they will be used in the right places. Okay, so let's see what is severity. Severity refers to the impact of a defect on the functionality. So it is basically the impact. There is a defect and the impact of the defect is huge because it's being that particular functionality is being used by a number of people, a number of users, and if this doesn't work, it will impact a large user group. So if you know that generally the good QAs, after they get some experience and some maturity within the application, when they know their user database, then they will be able to give a good idea, a good indication about what is the severity. I know that this is a key functional area and this is being used by a lot of users, then I know that the severity, if it doesn't work, the severity will be high. If for example, if even if you don't know the user base, sometimes if you know that there is a bug, like for example you're not able to log in, so that will impact almost all the users, right? So the severity is automatically critical for that. If that if that sort of information is not working, if that sort of functionality is not working. And for example, if you are using some data loading in your application, and if the data loading is throwing some, errors, it's the page itself is no is throwing some exceptions and it is not available for the users, then again that is a kind of critical defect. So you know that, if you know what sort of functionalities are really important core for your business, then you will be able to give it very, in a very good indication you can give about the severity. Whereas priority refers to the urgency with which a defect needs to be fixed. If I say the priority is high, that means I want the defect to be fixed quickly. And if I say the severity of the defect is critical, maybe it needs to be fixed urgently as well. But the usage is different here, right? And sometimes, even though the severity is really high and the priority is low, and that bug can cause significant damage but can be fixed at later date. So that means, maybe, if the severity of a particular page, let's say an example of a loader, so that is not working, so you know that the severity is really high because the page itself is not working, the functionality is completely failed, you're not it's not even accessible. But if the business side, if they know that, oh, this particular loader is not being used by anyone, there are no users using it, so it can wait and we can fix it in a next release or in a later date. So that's how these terms are used. So basically, one is referring the impact and the another one, priority, is referring the urgency. And severity measures how severe the issue is and how critical it is to fix it. Priority measures how quickly the issue should be resolved based on the business impact or the project timeline. Then this is classified as low, minor, major, critical. So low is being really low severity and critical is the most important or most urgent. Then priority is classified into different levels such as high, medium or low. And as I said, high severity and low priority status can cause significant damage, but sometimes it can be decided to fix at the later date. Then high priority and low severity status means that the bug must be fixed immediately, but it does not affect the software too adversely. So sometimes even the low severity, I know that the severity of this defect is low. That means it's not causing much impact to the software. But I can say it is high priority. Maybe the product owner comes in and they say, oh, even if it is a low severity, this particular functionality is very famous. It's been used by so many people and they may not like it. They may get annoyed. If more people are getting annoyed, we may lose the business. So that's why even the low severity can get into high priority and that must be fixed immediately, even though it is not impacting the software too badly. So these are the main differences. I hope it's making more clear now. Thank you so much, and we will see you all with some more important and good interesting questions in the next video. Thank you.